Question number 12, using the second derivative test to classify critical points. So first we'll find the critical points as we did previously, but now we're going to classify them with the second derivative test. So I have the template I came up with. Again, we'll sort of in progress, but let me know if you need anything. So first we'll go ahead and write down the function itself. So you can print these out and actually write on them, or you could just write on a piece of paper and use them kind of as a guide for all the steps that you will need to take. So I'm just going to copy over the function that we're working with. We need to find both first partial derivatives. It's a little confusing, but there's the partial derivative with respect to x and partial derivative with respect to y. So first, with respect to x, derivative of x is 1, and then y squared is a constant, so that just tags along, so 1 times y squared. Negative 6x squared, so we take that derivative. 2 times 6 is 12, negative 12, right? And x to the first power, subtract 1 from the exponent. The last term is 0 because it's got a y, it's just a constant, so you take its derivative with respect to x, that's 0. We're going to skip over these for now. We're going to do the first derivative mode, so now we take the first derivative with respect to y. So we come back up here, and this first term, the first derivative with respect to y is going to be 2y times x. So we'll leave the x in front. Actually, let's do it this way. I don't know why that. We'll put the 2 in front. Let's start over. 2xy. How about that? So that's that. Come to the second term, x squared. That's a constant, so that whole derivative of this term is 0. The last term, 3y squared, the derivative of y squared is, the 2 comes down, so 2 times 3 is going to give us a negative 6 y to the first power. So that's the first derivative. Here's the first derivative with respect to x. Here's the first derivative with respect to y. Now we go about finding critical points. We can kind of skip over them, but what I wanted to do at this time, I think it would be appropriate to go ahead and take the second derivatives, because we're going to use them later. So we'll use the first derivatives to get the critical points. So we'll set the first derivatives equal to 0, solve for x and y, that gives us our points. And then we'll apply the second derivative test, but for that second derivative test we're going to need the second derivatives. So while we're in calculus mode of taking derivatives, why don't we go ahead? So this here is the second derivative. It's taking the first derivative of x with respect to x. So there's a y squared, that's a constant, that's a 0. That's the derivative, that is 0 down here. And then we come to minus 12x, take that derivative, that's just going, because x becomes x to the 0 power. So this derivative is just negative 12. Over here we're going to still use the derivative with respect to x, the first derivative with respect to x, but this time we're going to take that derivative with respect to y. So we come back to this one here, and taking the derivative with respect to y, y squared will become 2y. Negative 12x, x is a constant, this part becomes 0, so the second derivative of x with respect to y is 2y. Now remember, we should get the same thing down here. Sometimes we could say, okay, we will, so we could write it in, but we're going to do a check, okay? So now we're going to take the second derivative. We're going to start with the first derivative with respect to y, right? That's what that first y means, and then we're going to take it with respect to y. So we come up here, 2xy, take the derivative with respect to y, and what we get is 1. Y, derivative of y is 1, so what's left is 2x times 1, 2x. Second term is negative 6y, take the derivative of y as 1. 1 times negative 6 is negative 6. So that's that. Taking the derivative of taking the first derivative with respect to y and making it the second derivative, we're going to take the derivative with respect to x on it now. So we'll come back up here. This term, derivative of x is 1, so that becomes 2y. Well, that's cool. And then we take the derivative of 6y. Well, y is a constant in this case, so that is 0. That's exactly. So these two are identical, which is exactly what we wanted. Okay, so we've got second derivatives. Maybe we'll use a different color. So these are second derivatives, and yeah, these are first derivatives. I'm not quite sure about the formatting this. You might find something that works better for you, but I just want you to see that when we take the derivative of the partials, we get two partials, partial of it with respect to x, partial with respect to y, and then the second derivatives, we get two second derivatives off of each of those first derivatives, so 4 second derivatives. Okay, critical points. Now what we've got is we've got these blue ones, the first and second, and what we're going to want to do is so the suggestion is, well, we got to set them both equal to 0 first, so not much else to do. So I'll take the derivative with respect to x. We've got y squared minus 12x equals 0. And then we've got the derivative with respect to y, 2xy minus 6y equals 0. Now, what we've got to do is solve these for x and y. So I'm going to look over here. This looks like a nice the partial with respect to y. I'm going to just kind of go over to the scratch paper because I can factor out how about 2y? 2y comes out, so what's left inside is x minus 3 equals 0, right? So we had 2xy minus 6y equals 0. Factored out a 2y, and we've got 2y, x minus 3 equals 0. So we get 2y equals 0, or, because these are two things, right? This is 2y is one thing, x minus 3 is another thing. They're being multiplied, and they're equal to 0. So the 0 property says is they could both be 0, right? Not necessarily at the same time, but anyway, they do. So this one we divide both sides by 2, and we get y equals 0. 0 divided by 2 is still 0. Over here we add 3 to both sides, and we get x equals to 3. Now we're going to check it in the other equation. Let's see what happens. So we also have y squared minus 12x equals 0. So if we put in 0 for y, that gives us 0. And if we put in 3 for x, that's not, we're not going to get 0. So what we're going to do is we'll take this, put 0 in for y, and if that's the case, we got zeros on both sides. Divide, subtract 0 from both sides. I mean, basically that 0's gone, right? We would add 12. No, not add 12. We're multiplying, so we divide by negative 12. Divide by negative 12, and we get x equals 0. So if y is 0, x has to be 0, right? Because otherwise this would not, these have to simultaneously be the same, the correct, right? So if y is 0, x is 0. Now let's see if that happens up here. If y were 0 and x were 0, this would still be okay. Y is 0, even though x might be something else, but if x were 0, 0, 0, so that works. So this point, when y is 0, x would have to be 0. Okay, so that's a point that works. Now we can plug in 3 for x down here, and let's see what happens. So let's come over here. Y squared minus 12 times 3 equals 0. So we get y squared. 12 times 3 is going to be 2436. Add 36 to both sides. And we end up with y squared equals 36. Take the square root of both sides, and that gives us that y equals plus or minus 6. Because it could be either positive 6 or negative 6, right? You square it and take a square root. So this was the case when x was 3. So that gives us 2 points, 3, negative 6, and 3, positive 6. Now let's, so we know it works in here. Let's see if that would work up here. Well, if x is 3, we get 0. It doesn't matter that y is 6, because check it out in the original, but you can see once x is 3, this is 0, so it doesn't matter what number this is still going to be true as long as x is 3. So we've got 3 points, and I forgot to check the answer to this as I'm working it, so if I'm wrong, I'll just delete this thing and start over again, but we'll see. So those are our 3 points, and we now need to determine whether they are a, what is it? Whether they're a minimum, a maximum, or a saddle point. So let's go with the 0, 0 first, right? So we're going to come up with this Hessian. It's the first derivative at the point, second derivative, first derivative, this is called the second derivative test. It's the second derivative of x with respect to x times the second derivative of y with respect to y. Those will get multiplied, and then you subtract sort of these two that are cross, or you square them, right? So let's just kind of go what the Hessian is going to look like. X with respect to x, that's just negative 12, so that's always going to be negative 12 regardless of the point. That's going to get multiplied times the second derivative of y with respect to y. See, that's this one here, so 2x minus 6. And then we're going to subtract, let's go with the 1 squared, it might as well, right? So then we're going to take 2y, or 2y times 2y if you want, squared. So that's this part here. So we've got our Hessian set up, and now we want to try for each of these points. So let's try 0, 0. So we think, okay, negative 12 still there. If this is 0, that becomes 0, that's negative 6. So we get negative 6 times negative 12 is going to be positive, some big number, 72. I think that's correct. Again, all we're looking for is the sign. What did I say, 72. This one, when you put in 0, that becomes 0. You square 0, you get 0, so minus 0. So that's the Hessian is positive. So, okay, that's right there for 0, 0 anyway. It's positive, and then so what we look at, what is x with respect to x, x with respect to x, well, that's always negative 12. It's always negative 12, so that's a negative. So this point 0, 0 is a maximum. It's a relative maximum. And again, you might think, well, that's, and again, if we plug it in up here, that's going to give us a z value, actually a z value of 0, right? But for some reason, that's going to be a maximum. Must mean that everything else is negative or something. Okay, let's go ahead and use the Hessian for the point 3, negative 6. So we plug in 3 for x. Okay, so we got negative 12. Let's go ahead and walk through this. This is 2 times 3, which is 6, minus 6. that's going to be 0. 0 times 0 is 0. Let's see, what do we get back here? We get 2 times y times negative 6. Square it. So 2 times negative 6 is negative 12. You square that, you're going to get 144. And that negative on the outside sticks on there. This all becomes, since this becomes 0, 12 times 0 becomes 0. So our Hessian now is negative for this particular point. That means we have a saddle point here. And I'll bet, since it's usually they're sort of balanced, that maybe this is also a saddle point. So again, what we want to do is, I guess we're running out of room, but that's the beauty of having two things set up here. So we're going to get negative 12 times 2x minus 6. X in this case is going to be positive 3. So 2 times 3 minus 6, which again is going to be 0. 0 times 12, so the first part of the term is 0. We get a negative 2 times y. Y is 6. I'm going to square that. 6 times 2 is 12. 12 squared is 144, and we still have this negative on the outside. So yes, indeed, that gives us a negative Hessian. Negative Hessian. This one is also a saddle point. Okay, and so first find the critical point of the function, or points, I guess. I got 3. And then classify the critical point found in part A. And I guess we should have S's on these points because we found multiple points. I'll check the answer against the key. If it worked, then this video went through. If not, you'll never know about it because I'll just delete this thing and I'll start all over again. But I'm pretty sure about this. I just haven't checked it. But this is the process of using the second derivative. So we take the first derivatives, take the derivatives of the derivatives. We have all that. Find critical points by setting them equal to 0. And again, that's simultaneous. So whatever values of x and y we come up with have to work in both equations. So we solve for those, and then we're going to need to remember this Hessian. Now, I've got them in these forms. You may want to print out multiple sheets or something, or adapt it. It's a Word file. But I believe over time, you'll be able to see, okay, just take the second derivatives that are with the same, xx and yy, multiply those. Take the two that are not the same, xy and yx, and multiply those, and then just subtract them. So remember it that way. I think will be a little easier, or square them like that. And then what you do is, once you've got your critical points, in this case we had 3 of them, you plug them each into that Hessian formula, and the part to remember is, if it's positive, then we've got a minimum or maximum. If it's negative, we've got a saddle point. And then if the h equals 0, then we don't know anything. We can't classify it. All right, that's it.